Secular Center event here, if anybody is interested. And with that, I will turn it over to Diane.
Good afternoon. A couple of things. First of all, we need someone to sign up for the different humanist moment. I don't know what you're going to call this. We'll just call it a moment. All right. I'm going to share then some selections with you from this particular book. And even if you already are an expert in philosophy, you might just enjoy reading it just because maybe you'll get the jokes more than I did, even deeper, have a deeper understanding. But one thing this book made me realize is that that I had never even realized in my whole life is that from an early age on, when I first began telling jokes then until now, that every time then, or many times when I've been telling a joke, not only have I been funny, but also very philosophical.
What's the name of the book?
It's called Plato and a Platypus Walk into a Bar. I mean, that you can't miss that title. What other book would have, you don't need the author's names because you're going to find it. Plato and a Platypus. And they also have a book out that I haven't gotten yet. It's something about an aardvark and so. And I think Aristotle and an aardvark walking about, and that's about history told through jokes. Awesome. Time for
Whose list is this?
I guess Roxy's MIA, so I'll have to introduce myself.
Oh, okay, yes.
Hi, I'm Steve Jordan, and someone just walked off with my speech.
Oh.
Where's your teleprompter?
Yeah, let's see if I have the last page too, or if I have yours. I do, I have more of yours.
Plato did that.
Trying to pass stuff off to me.
Check your wallet.
Well, I guess I'll just introduce myself. Hi, I'm Steve Jordan, and I'm not quite sure what I should be saying to introduce myself. I have an active interest in the Singularity because I see the possibilities, and I think it's really exciting, and I'm really grateful that you've given me the opportunity to come here and tell you about it. Well, anyway, so good afternoon. My name's Steve Jordan, and I'd like to take you on a trip into the future. You probably remember it well. Oh, yeah, slide. How's that for a misnomer? Anybody remember dialing phones? When was the last time you dialed a phone? The future ain't what it used to be. In 1893, as part of the Fourth Columbian Exposition, the Newspaper Guild invited 74 leaders of the day from various industries and all walks of life to speculate what the world would be like 100 years hence. Their essays were published in the newspapers in the weeks preceding the exposition. In 1993, historian Dave Walter resurrected these essays and collected them into a book called Today, Then. What is most striking about this collection is how few of the predictions actually made came to pass. Only 5 of the 74 authors discussed features that resemble the world as we know it today. The others confidently predicted that technology would eliminate the distinctions between haves and have-nots, reduce postage to 1 cent, eliminate most crime, give people time to advance their educations, reduce taxation, and limit the scope of government. They predicted the United States would encompass all of North America and approximately 60 states, and that railroads would be the primary means of transportation. Pneumatic tubes would move people around cities and be used for transcontinental mail, and that aircraft would be limited to military applications. Only a few foresaw universal electric power and telephone, a communication system resembling the internet, or the doubling of expected lifespans. No one foresaw world war, interstate highway systems, genetic engineering, mass state education, broadcast radio or TV, or the computer. We may not know exactly what our future will look like or when it will come to be, but there are a number of features that we can extrapolate and a surprising degree of confidence we can have about when they will come to be. Allow me to introduce Ray Kurzweil. Born in 1948, Ray is an inventor who's been making life better for people since the Kurzweil reading machine made it possible for blind people to read printed books in 1976. His inventions in OCR, speech recognition, text-to-speech synthesis, electronic music, medical transcription, and others have led to his description as the ultimate thinking machine by Forbes magazine. Inc. magazine ranked him number 8 in entrepreneurs in the United States, calling him the rightful heir to Thomas Edison. PBS included him as one of 16 revolutionaries who made America, along with other significant inventors of the past 2 centuries. The Singularity is Near is a book written by Ray in 2005. It is a sequel to 2 previous books on much the same topic. His first book was The Age of Intelligent Machines, and it was published in 1990, 3 years after the documentary of the same title. His follow-up was called The Age of Spiritual Machines, published in 1999. The Singularity is Near was a New York Times bestseller and has been the #1 book on Amazon in both science and philosophy. Linear growth. First, a concept. Linear versus exponential growth. These are mathematical concepts and they're not terribly complicated, but they're really critical, so you'll excuse me if I'm going to beat them to death for a few minutes. Linear growth is simply constant increase. If you manage to save $1,000 each year, after 16 years, there would be $16,000 in your pickle jar or under your mattress or wherever it is you'd be keeping this stuff. This is simple arithmetical growth. On the other hand, there's the story about the guy who invented the game of chess. When his emperor asked him what reward he wished, the man said he wished 1 grain of rice for the first square of the chessboard, and 2 grains of rice for the second square, 4 grains of rice for the third, and 8 for the fourth, and so on, with each square being worth 2 times the value of the previous square. For ease of calculation, let's assume that a grain of rice is worth 1 cent. In fact, it's actually probably worth 1/100 of a cent, but for comparison, let's also look at how much he would have received if he had asked for $1,000 for the first square, and $2,000 for the second square, and $3,000 for the third square, and so on. On this graphic, the blue bars represent the value of each square at a rate of increase of $1,000 per square in blue. By the time we fill the first 2 rows, the amount of money represented by the double the previous amount is barely visible. You see the little red speck down here in the bottom right? At this point, one could be forgiven for assuming that the man was a fool. But let's continue the extrapolation 2 more rows. It's both intuitive and apparent that the $1,000 per square scheme at D8 is $32,000. The total value of the squares at this point would be $528,000, and that's only half of them. Way down here is the doubling every value square. It's barely a nub. In the back, you may not even be able to see it. But as we continue this doubling every square scheme through the next 2 rows, it's apparent that this was misleading. It's now a completely different game. The value of each square just took off like a rocket. In fact, the magnitude of the last of the 4th row cannot be fully appreciated unless we zoom out. Notice that the top of this first scale is at $100,000. The top of this scale is $12 million. And the value of D8 is actually up here someplace, above the top of the screen. But the data displayed here are the same as the previous graph. It's scaled like this so that you can actually see the relative values. This is the $1,000 per square scenario. Even the total value of the squares to this point is only a quarter of the way to $2 million, $528,000. This is exponential growth in action. As you can see, for a long time it looks like a horizontal line. But then at some point it just explodes in value. It looks more like a vertical line. And this is nothing short of awesome once it gets going. And remember, this is just the first half of the chessboard. This is an old concept, and many of you were probably introduced to it in school as an example of compound interest. I think I was in junior high, and I started looking for a bank that offered such a product so that I could get started. I was going to smash my piggy bank, and my father assured me that this was not a real-world example, that's just a demonstration of compound interest. My piggy bank, I'm sure, breathed a sigh of relief. But guess what? There's a real-world arena wherein we are experiencing demonstrable, exponential growth like this, and have been for over a century. The field is information processing, and we'll look at why you should care after a little more exposition. In his book, Kurzweil divides the history of the universe into 6 phases. The first, physics and chemistry, is the fundamental setting up of the conditions of the universe, the physics of the horrendous space kablooey, or Big Bang as it's sometimes called, and the so-called life cycle of stellar fusion eventually producing the varied chemistry found on planetary surfaces. From the time of the Big Bang to the frequent occurrence of planets was likely only 1 billion years or so. Our own solar system was formed about 8 or 9 billion years after the Big Bang, about 4.6 billion years ago. The first epoch started at the appearance of the universe, back here someplace. Notice that the scale of the x-axis down here is logarithmic. This is 10 years ago, 100, 1,000, 10,000, 100,000. What we call life started when chemicals that could duplicate their own structure by assembling local materials began to do so. The second epoch dawned with that innovation. At that point, chemistry became biochemistry. as DNA, the record of successful solutions, carry the information forward of only those things that could reproduce in this way. The cycle is self-reinforcing, favoring solutions that make the most copies of themselves, but it is excruciatingly slow. The first self-reproducing entities probably appeared on this planet 3 billion years ago. The first algae and fungi about 1.4 to 1.8 billion years ago. The life of this period processed the atmosphere to the point where significant amounts of free oxygen were present, which made possible multicellular organisms, where cells had specialized functions. Such life forms became significantly more diverse about 1 billion years ago. Here, eukaryotic cells. This type of evolution continues even today. The third epoch took a few 100 million years to get going, but it's about brains. It started somewhere around that point, when cells could specialize to function as neurons, while the second epoch relied entirely upon DNA to carry good solutions forward. Brains take information delivered to them from sensors of various types about the environment, recognize patterns in it, and direct the bodies in which they reside to take action, to eat something, for instance, or to prevent itself from being eaten. As this ability evolved, brains developed in ways that allowed life forms to adapt their behavior to take the greatest advantage of their immediate surroundings, to repeat behaviors that allowed them to survive and subsequently reproduce. Consequently, brains that were hardwired to behave in ways that ensured an individual's survival were able to propagate the species as those individuals reproduced more than others. Such things began to play a role in evolution as brains wired for advantageous behaviors exploited new niches, for example, and thus expanded the range of a given species. Even today, some species can be distinguished from each other only by their behaviors. In the case of our ancestors, it allowed them to develop abstract mental models of the world, to recognize patterns in those abstractions and not just the world itself. Brains, which preserve behaviors of species, leverage the power of physical evolution to allow various species to better adapt to their environments and thus to be perpetuated, which launches us into the fourth epoch, that of technology. Technically, this started when some animal used a stick to dig bugs out of a hole, or some similar use of tools. At least 2.5 million years ago, flint chips were being used as a hunting aid. Vines were later used to tie sticks and other things together and build structures. Pottery took dirt and turned it into vessels. Metalworking evolved, which gave us sophisticated and robust tools, which could in turn be used to make other, even more subtle and more powerful tools. Thanks to writing, when people learned something, they could send that information into the future for others to build upon. Domestication of other organisms leveraged our analytical powers and the greater strength of larger animals. At what point is the fourth epoch in full swing? It's a subtle point, and answering it doesn't really tell us anything, but it's still advancing. The Industrial Revolution put our tools to work for us, powered by something more robust and more precise than muscles. Our mental abilities were massively leveraged, but bigger things were still to come. Electronic computers. I'm going to pause in this review of the 6 epochs Kurzweil covers because we've reached approximately the point in time where we are today. The fourth epoch may have been applicable to humans 40,000 years ago, but it's been the hallmark of our age since the development of the scientific method about here, and more obviously since the Industrial Revolution. This is because the rate of technological innovation is accelerating. It has been accelerating since it started. It's a demonstration of the law of accelerating returns. Leverage the work done before to do something even better, or do it more efficiently. For example, computational horsepower took 3 years to double back at the beginning of the century. By the middle of the 20th century, it took 2 years to double. You'll notice that the curve is going up faster as it goes. By the end of the century, today, actually we're out here someplace, it's doubling every year. The kind of computing horsepower and storage that once constituted a supercomputer that cost hundreds of millions of dollars to manufacture, maintain, can now be built from off-the-shelf components for about $2,600. This tiny twig of a device with absolutely no moving parts can store 32 billion bytes of data. This is more information than there was in the entire world 50 years ago, maybe even 40 years ago. And you can go to Micro Center right now and buy one for $60. It's worth noting that this acceleration continued even as it passed through 5 distinct types of computing technology: electromechanical, relay, vacuum tube, transistor, and today's integrated circuit. What's the next technology? No one's really sure yet, but it makes good talking. Here's our doubling per unit time investment graph again. The point at which the curve goes from horizontal to vertical is sometimes called the knee of the curve. It's where the tangent of the slope is at 45 degrees. We've crossed the knee of the curve. Technological innovation, driven by information processing, is about to start climbing faster than most people have imagined or can even fully grasp. The information in the computing chart a moment ago can be presented in such a way as to put that knee almost anywhere. But the way we ground this information and make it relevant is by putting it in relation to known fixed values. Computational speed relates directly to cognitive abilities. Here are the relative processing capabilities of some significant historical computers plotted in relation to known organisms. Notice that the vertical scale is logarithmic, and this is linear, which makes it harder to go up as you go forward. In spite of this, notice the trend. Not only does it climb, but it climbs faster as it progresses. Note also that these data points represent decreasingly exotic equipment. In 1920, the IBM tabulator was commissioned by the United States government to make the census possible. In 1940, that high point there is the Colossus used to crack Nazi war codes. There were 3 of them built. Somewhere smashed into 1960 is the IBM 7090, an IBM business mainframe. Around 1980, we have the revolutionary IBM PC, your actual personal computer, which at the time was revolutionary. In 1997, up here at the very top, we have Gateway's G6200, which is when this graphic was produced. It uses one Intel Pentium Pro CPU at a blistering 200 megahertz. Let's put some more references on this axis and zoom in for a little more detail. The trends are more apparent now. We can even predict where we would be if the trend had continued at rates specific to various times. Notice that here, the 1965 trend would have given us the computational abilities of a spider by the year 2000. But as we get closer to 1995, we realize that by the time we get to 2000, we're really going to have something more on par with a lizard. It doesn't sound like a lot. But this is with a desktop class machine typical of the late end of this chart, though it would require the dedicated resources of the entire machine to do so. Any curiosity about what world-class supercomputers can do today? Here is a chart of supercomputer power that was created in 2005 for the publication of this book. Notice that there is a trend over time from slightly behind the curve in the 90s to slightly ahead of the curve by today. Also note the number of machines that were already planned to start operation, these open circles, were known in 2005 to be at least in the design phase at that time. Oh, and here's a teaser. A program called the Cortical Simulator, written for BlueGene/L, which is this guy, has already simulated 8 million neurons with up to 8,000 connections each in real time. It's only about half a mouse brain. This next graphic is for the same chart, but updated for 2009. You'll notice that all the planned slots have been filled, and that one machine that was not even known to be in production at the time, IBM's Roadrunner, is the current top-reigning rip snorter at 1.1 petaflops. A flop is a floating point operation per second, and a petaflop is a billion floating point operations per second. That's about 6 orders of magnitude more powerful than what your $1,000 desktop machine will do today. 1,000,000 times the processing power. Imagine 1,000,000 desktop machines altogether to equal that one supercomputer. Currently under construction is the latest iteration of IBM's Blue Gene series, Blue Gene Q, which will churn along at 20 quadrillion operations per second. These machines get their power by massive parallel processing, hundreds of thousands of CPUs wired together just like the human brain, which gives them the similar architecture. Also note the relative processing power of Deep Blue down here in 1997 when it whipped Garry Kasparov at chess. Roadrunner has already been used to briefly simulate the human visual cortex as a way of benchmarking the machine's performance. Researchers are planning to study it in real time. The computer can interpret visual information in the same manner and speed as a human. Pessimistic estimations of human neural capacity put the brain at 100 petaflops. If this is true, by 2013, supercomputers will be able to simulate all the functions of the entire human brain in real time. The benefits of faster computers translate into benefits in every information-based industry, as it allows those industries to advance more rapidly. Consequently, advances come at an ever-increasing rate. These advances are further leveraged by the fact that information technologies are dropping in cost as well. A workstation on par with Deep Blue of 1997 can now be had for under $3,000 today. A twin CPU Xeon quad-core at 2.44 gigahertz or faster. You can buy them up to 3. Today, each dollar spent in R&D generates a higher ROI than it did in years past. All industries that use computers benefit from this. So where is AI today? As a measure of artificial intelligence, consider DARPA's Grand Challenge Contest, 3 successive efforts to demonstrate driverless cars in 2004, 2005, and 2007. These are the 4 top finishing cars from 2007. In 2004, none of the contestants even finished the 150-mile course, and only 1 completed even 11 miles of it. The next year, in 2005, only 1 entry didn't finish at least 11 miles, and 5 of the 23 contestants finished the entire course, only 1 taking more than 10 hours to do so. In 2007, the race was made more difficult, with 96 miles of urban driving. 6 teams completed the entire course. This new challenge required cars to autonomously perform sophisticated interactions with each other and with 30 manned cars on the course. They were also required to obey all California traffic codes, such as maintaining precedence at a 4-way stop intersection. Continuous speech recognition systems are already deployed to answer phones at companies like American Express, USAA, UPS, and in functions such as medical transcription, voicemail direction, and training of air traffic controllers. Today, we can mass-produce rudimentary systems with their own sensors, endow them with information processing abilities, and set them to work almost autonomously. From the Cassini-Huygens probe to Roomba vacuum cleaners, the age of AI has dawned. Thus, with the 5th epoch begun, only just, Kurzweil believes humanity will integrate with the artificial intelligences that it is creating. The knowledge in our brains and our books is being transferred to manufactured substrates where it can be accessed more efficiently, and engineered components are being installed in our bodies to enhance or repair us. We are already beginning to incorporate non-organic components into our bodies to restore faculties lost to accident or disease, or even entirely for the sake of appearance. Examples include retinal CCDs, hip and knee replacements, artificial hearts, cochlear implants, insulin pumps, hearts, and the still fairly new neurological pacemakers, even things like breast augmentation or replacement, just to name a few. Do users consider these cybernetic additions to be part of themselves? I can state with conviction that we do. We understand this of others, too. One would no sooner wrest an artificial leg away from its owner than tear off her ear. It has been part of our language since we started wearing clothes. My shirt or my leg denote a sense of possession. The next logical step is for products to enhance our brains from the inside. As we become less subject to the foibles and compromises of evolutionary biology, we'll benefit from the intelligence that we can design into our new engineered biology. The advances being made in computing are leveraging the advances in genetics, nanotechnology, and robotics, collectively referred to as GNR. In 1990, when the Human Genome Project started, progress was so slow and expensive, there were criticisms from around the world that it would never be finished in 100 years, let alone the 15 that were currently slated for it. But as the technologies were refined, the cost dropped and speed increased exponentially. The genome was over 92% complete in 2003, 2 years early. Sequencing the centromeres and telomeres will have to await a more subtle technology. Thus, the refining work continues, but the project demonstrates the leverage of the law of accelerating returns. The cost of gene sequencing continues to plummet. Complete Genomics says they'll be able to sequence your entire genome this summer for $5,000. While there's still a lot of study to be done, the era of personalized medicine is dawning. The health benefits of this are almost inestimable, because it will be known with increasing certainty how drugs will interact with your personal biochemistry and phenotype. Complete DNA and protein microarray systems for nanoprint desktop manufacturing can be purchased for $18,000, or under $27,000 with all the extras and goodies. This is a 20th of what such systems cost 20 years ago, if you could even find a turnkey system from one source. So, what about nanotechnology? Nanotech. Oh, by the way, the word nanotech is up here. It's just so small you can't see it. The number of patents issued each year in nanotechnology has been increasing steadily since the mid-1990s. Eric Drexler's visionary book, Engines of Creation, has proven a surprisingly accurate picture of nanotechnology's development since its publication in 1986. That's 23 years ago for anyone who's counting. The range and scope of nanotech's reach is vast. The Radius rollable display from Polymer Vision in Southampton, England is already in production. Surface conduction electron transmitter displays, or SEDs, that consume 1/10 of the power of LCD and are brighter too. 3D spintronic circuitry, Nantero's NanoRAM memory, and HP's Memristor. Solar cells, an order of magnitude more cost efficient than what we have today. Lighter, stronger materials for automobiles and aerospace. But nanotech's most profound impact will be in medicine, as we learn how to directly interact with, repair, replace parts of, or even redesign our bodies. Consider the possibilities of lab-on-a-chip devices, Robert Freitas' hypothetical respirocytes, an artificial type of red blood cell that would allow you to hold your breath underwater for 4 hours. and that holy grail of personal industry, desktop computer-controlled molecular manufacturing. Today, we have fabathome.org's $2,400 personal open source Fabber. Houston is a nanotech hotbed. 2 of the 3 1996 Nobel Chemistry Prize winners serving as professors at Rice University's nanotechnology program. The Nano World Headquarters is currently pursuing solutions to a diverse array of problems: an energy-efficient grid for the nation, cancer cures, low-cost, high-energy rechargeable batteries. They'll be at booth 905 at the Nanotech Conference and Expo, May 3rd through 7th this coming month at George R. Brown. Buy your tickets now. It's right around the corner. Robotics. Robotics and cybernetics continue to make ever-increasing advances into daily life, in manufacturing, assisting the disabled, even picking up the trash. Household robots are already common. They clean pools, vacuum floors, wash dishes and clothes. Toyota plans to release an Android household robot in 2010, primarily targeted at elderly users. Among other tasks, Honda's Asimo can take a tray from you, deliver it to a table, hold your hand while you walk to provide stability, and run at up to 6 kilometers per hour on 2 legs. Waseda University's 21 can scrub your kitchen, get a ketchup bottle out of the fridge, and deliver the food to your table, just to name a few of its capacities. Korea plans to put such a robot in every household in the next 10 years. Sure, there'll be some issues with it, but the whole country of beta testers, think of the advances that they're going to be able to make. Hanson Robotics is currently showcasing Jules, an interactive animatronic whose face automatically mirrors your own expressions as he holds limited conversations. Change his wig and vocoder and he becomes Joey Chaos, Agent of Change. Hear him have a conversation on YouTube. Emotive Epoch. Science fiction is rapidly becoming science fact. $300 will buy you a first-generation thought control interface for computer gaming. This device was manufactured by Emotive and is called the Epoch, slated for demonstration at Best Buy this August. The Epoch can already simulate your facial gestures, like this, detect moods, and simulate Jedi-like powers using thought alone in games of telekinesis. Today, such technology is little more than proof of concept, but so were telephones when they were first commercialized, or cars. Look at how long it didn't take for cell phones to shrink from the 5-pound car batteries to something the size of a bar of hand soap. The hardware capacity of computers will equal that of human brain in a few years. The software is a little further down the learning curve, but that's taking off quickly too. What's required to take artificial intelligence software to the level we thought we'd have in the 21st century? Brain scanning. We'll simply reverse engineer the 1.0 version. Spatial and temporal resolution of brain scanning is doubling every year. Electroencephalography, positron emission tomography, magnetoencephalography, computed axial tomography, magnetic resonance imaging, and its variant functional MRI are adding increasing clarity to our understanding of what the brain does and exactly how it does it. Thanks to reverse engineering efforts of the brain, it seems conservative to estimate that by 2030, your basic $1,000 desktop machine should be able to pass the Turing test. It will be able to hold an extended conversation on a variety of subjects, and humans will be unable to tell the difference. That visual cortex that had been simulated on IBM's Roadrunner will be simulated in detail over the next few years. Simulating a human brain will have to wait for Blue Gene/Q, but within 10 years of its doing so, your desktop machine will be able to accomplish this, or at least a significant fraction of it, so as to be a helpful assistant instead of a dumb machine. At that point, machines will quickly become capable of designing and upgrading themselves. Machine intelligence will improve and extend its own capabilities in a feedback cycle that unaided human intelligence will be unable to follow. This cycle will also accelerate as improved machines redesign themselves better and faster than their predecessors, specifically us. The sixth epoch dawns when strong AI, machines with intelligence that exceeds our own, have the ability to improve themselves. Whether they will be humans with enhancements or engineered cybernetic AIs remains to be seen. Either way, they will be our descendants, and the first generation, the prototype, will be among us within 5 years. They may only be in laboratories, but so were iPods only 8 years ago. Oh, and to date, 178 million iPods have been sold. Of course, there are naysayers. I'll try to address a few of them. There are limits to, for example, computational capacity imposed by the size of atoms and thermal tolerance. But the best example we have to date of a massive parallel computer lives inside your head, designed by evolution. Engineering can provide better answers than this, and our first example will light up within 5 years. It'll be on your desktop about 10 years after that. AI critics say, we may have the hardware, but our software is stuck in the mud. Well, experimental AI research of the 90s are everyday apps today. As our neural scanning resolution increases, our understanding of the brain grows as well. A complete understanding of the brain's processes may not come until after we've analyzed our own recreation of it on a silicon substrate, but problems become much easier to detect and simulate, and solutions become easier to design and refine. If you still don't think we've come a long way in 20 years, dust off your old 386, boot into DOS 5 or Win 311, and start WordStar or DBase, and see if you can get work done with the expectations of today. Welcome to the 21st century. Conspiracy theorists might postulate that vested interests in energy and transportation are too well entrenched to allow such rapid change. Well, the transfer of information is not affected by these things, and that's where the acceleration is most evident. An economist might argue that only the rich are able to afford new technologies. Well, the rich may get them first, but as demand ramps up, so does industrial efficiency, which makes the tech accessible to everyone. The future is here. It's just not evenly distributed yet. It was big news when several clients queued up to pay GNOME $350,000 to have their entire genome sequenced in late 2007. GNOME was able to crank the price tag down to $100,000 by mid-2008, and Complete Genomics beat Intelligent Biosystems only by a few weeks in taking it down to $5,000 by this summer. Did that price come down fast enough for you? It isn't done falling either. Where do we fit into all of this? I suggest that each of us take as active a role as possible. Join the conversations now and shape the design of things to come. There's no way to do this topic justice in 45 minutes. The long-range implications of it are simply staggering. This is just a starting point for the conversations about the effects of our technology on us, and what does it mean to be us? In one sense, we're building our descendants. In another very real sense, we have met our cybernetic successors, and they are us. I'll take questions now if anybody's got any. Yes?
The space we have under us, it's like past 100 years, we have a lot of baby family living having less children, creating less diversity in girls as we grow up. You know, since we have more people right now, we have less room in the world to actually hold people. So when we have more age, we'll have less diversification.
Would you amplify his question, please?
I'm sorry.
He's asking, are we going to have room for all the people that we're still producing? And
As more people are produced, how we evolve, we have more people to evolve us. That's how you're showing me what is that, the times 9, times 10, all that kind of stuff, how we're exponential growth. We won't have the same potential for exponential growth once we have more room time.
There are lots of technologies that can put us in space, such as a space elevator, and once we're out there, we can mine the asteroids or colonize other planets. Are also not taking into account, I think, the fact that industrialized countries, the birth rates tend to drop. And as this industrial technology is starting to be disseminated into the rest of the world, the birth rates are, in fact, starting to stabilize.
Yeah, I read the world population will stabilize in 2050.
Somewhere between 9 and 12 billion.
Something like that. It will start to decline very, very slowly.
Yeah. Yes.
There was a meeting in New York around June 2008, and Kurzweil made a prediction. I don't know all the details, but it had something to do with AI surpassing human intelligence within maybe 10 years. Or was it 15 years?
Well, by 2013, we should be able to simulate the entire human cortex on Blue Gene Q.
So almost surpass human intelligence somewhere between 2015 and 2020.
Oh, yeah. Then it'll become more common.
Also, I believe some software has been developed recently that humans cannot understand, solving problems that we cannot understand how to solve.
Oh, yeah. That was true many years ago. In fact.
Well, I wonder about was only the last couple of years.
Oh, well, that may be a desktop application as well. It's able to solve problems that humans can't quite puzzle out. But of course, once the computer solves it, then we can see how the computer solved it, and then we can understand what we didn't think of before.
I write software for a living. That happens all the time.
Oh, how excellent. Yes.
But you said about the machine that will pass the Turing test. When is that? When did you say it's going to be? Prediction?
Well, pessimistically, it'd probably be around 2020. Such a machine would probably be on your desktop by 2030 or 2025. It's only 15 years away. Anybody remember 1990? Yeah, Bill.
Ray wrote another book, Live Long Enough to Live Forever. And he took this same nanotechnology you're talking about and the exponential growth in medical technology, and he's living that idea that if you can just stay alive another 20 years, you will be able to extend your lifespan significantly, like hundreds of years.
Like just about as long as you want.
And he's testing his blood, I believe, daily, and monitoring all of his life signs, and he firmly believes that. And so that's and what is it? Tell me once again, what is singularity?
Well, technologically, I'm sorry, graphically, it's the point where, well, like when that, where it just takes off straight into the sky.
In other words, at the point where you're starting, it was practically flat at the beginning of the exponential growth, and then it gets to the other axis, where it's essentially extending forever into infinity.
Well, or for purposes of people who think $2 million is a lot of money, yeah, it gets real big, real fast.
Yeah, and then the next doubling is whatever the last one is. So the next one is just...
It's just awesome. Think about what's the second half of the chessboard look like? It's going to be in billions or trillions, quadrillions.
The word comes from the event horizon of the black hole.
Yes.
Where light falls.
And can't get back out, or physics breaks down, and we don't understand what happens in
Singularity was the Big Bang.
Yeah, that's true too.
I have lived, in town was Andre Kodesky. And he was talking about one aspect of this that he says that he just wrote a book about called the post-humanist era. And he's talking just about the kind of interbreeding of technology and humanity that's going to lead to a technological new species, next stage in the species. Human species.
Yeah.
Which kind of blows your mind.
It does, blows my mind.
You just talk a little about here, artificial knees and pacemakers and so forth. But of course, he says with miniaturization and so forth, that these things won't be some external device. Or you said Bluetooth. He says you're not going to hook things on your ear. Your babies are born, you're just going to implant.
Well, if I were that baby, I'd sure rather be able to say, yeah, I'd like one of those. Jim.
You talked about scanning the brain and using that as a model for these advanced techniques. One of the things about the human brain is its flaws, and it makes us what we are as humans. I mean, one of the flaws I always point out is the ability to forget. It's a feature, not a bug. It's actually a bug.
Yeah.
You have the ability to forget severe traumas and those sorts of things. When you reach the singularity, you would never forget. So how would they engineer in these flaws that make the human model better?
Well, I guess that's kind of a personal question. I would rather engineer in the ability not to forget, because I assume at that point I'd be able to cope.
It's part of the human coping mechanism, is the ability to forget the trauma that further that you the existence you get from.
Yeah. Well, I would hope that I'd be able to understand what happened and accept it as a fact and be very logical about it. Yeah, it's just a different kind of therapy. On the other hand, it would also be possible to simply delete a file.
Well, you would evolve into spot, in other words. Seems very logical.
That's another model.
Yeah, that might be, it could be evolved, yeah.
And you had another question?
Yeah, on your research, obviously you've done more than I have. But transmutation seems to be possible within this century.
Oh, foglets and like that?
I'm sorry?
Foglets and related technologies?
Say it again?
Foglets?
Follow that
Little nano robots with pinchers.
Nanotechnology, yeah, that's something else.
But they become anything that you want.
Yeah, maybe, but supposedly, some of our will be able to transfer matter and tension as one, aside from the nanotechnology. In other words, what you see on Star Trek, where they open the machine and say, give me a ham sandwich. It's technically possible.
That's it.
It will be technically possible within this section.
Yeah,
Also,
we're,
a life extension, basically, from what I see and what I believe will happen, is personality transferred into a computer, and that is how you will live for centuries if you so desire.
well, I might be on a silicon substrate, but I'll still be who I am.
You can be in a machine. If
Yeah,
you want to put it that way.
exactly.
Yeah.
Yes.
Because there's such a disconnect between this kind of technology and those millions of people out there that don't even believe in evolution. The disconnect is so huge. How do you see that ever being worked out?
I have agonized over that for hours because my family is deeply religious, and there are a number of very good science fiction books, such as Reality Dysfunction, that postulate such a scenario and then try to explain what would it be like with humanity divided effectively into two completely distinct species, one technologically advanced and one still wallowing in the mud.
What are the names of those books?
Reality Dysfunction by, I can't think of the guy's name, and a lot of stuff you'd find under cyberpunk headings. I guess the only reason I'll refer you specifically to Reality Dysfunction is a series of 6 books, and I found it very engaging.
Is that the technological person's answer to what were those books that life after, no, what was it? Gosh. They're all about the series of books that Jesus comes back.
Oh, Left Behind.
Yeah, Left Behind.
Left Behind. Ariel.
Yeah, that's good. Three things. One having to do with the point that Sheila brought up. Some 34 years ago, somebody went and looked into hot water puddles around Yellowstone and earned a, what was the name of it, a Golden Fleece Award for studying the sex habits of this strange bacterium that thrives in hot sulfurous waters. That led to all the DNA technology you're seeing now. Okay?
Pure research.
Yeah. Another thing is, when you got bar graphs here, instead of that you had a curve, it would be the exact same curve popularized in Inconvenient Truth, the so-called hockey stick curve, having to do with energy consumption. Now, someplace or other, we're going to have a problem with all this.
Well,
we're going to outrun our ability to do it.
We could. Depends on how fast these different things, technologies kind of dovetail together.
Yeah.
So that's like I say, one of the reasons I recommend you get into the conversation now and save the world.
Third thing is there's been at least 1 or 2 reports already that nanofibers and so forth and so on are capable of causing mesothelioma, which is the nastiest thing that asbestos can cause.
Oh.
What's going to happen when all these, infinitesimally small fibers get airborne?
Well, left unchecked, it would be a bad thing. And that's one of the reasons why organizations like Lifeboat and Kurzweil AI are working to get defenses against these things in place before they become a big problem.
Unintended consequences.
Yeah, that's why there's an argument going on between people who say we should stop right here and people who say we can't. Because if you say stop right here, someone is going to say, I don't want to stop right there. And they're going to find how to do something, and we're not going to have any defense because we stopped right there and they didn't.
There's so much of the world that's very far advanced and a lot of it's very behind. I was reading the other day about India, 1 billion people, less land than we have with our 305 million people. Their population density is 9 times ours. Mm-hmm. They've got more than half their people living in desperate poverty. They're cooking all their meals with dried cow dung patties and wood, making all this black smoke. In fact, the article said that all this black smoke from 600 or 700 million Indians cooking is adding about 19% of our greenhouse gases. And the black smoke is causing a lot of lung diseases and all that over there too. So it's a very serious problem and a very backward part of the world.
there's a Scandinavian inventor who just came up with effectively a cardboard box with foil that works as an oven. You know about this when you saw that? And so all we gotta do is start chipping over cardboard boxes and foil, and they can stop hacking down their own trees and stuff.
They're introducing solar heaters in Africa. Not the box.
Yeah, that's where he's using it, but this is certainly another place where we ought to be.
But India will surpass us. I believe that very much so. India and China, we're to look like pushing to them in about by the end of the century.
But they need to solve all their domestic problems then. They develop technology, but they don't solve problems like he was talking about then.
Totalitarianism?
That's what I'm trying to.
You can't stop them. You can't stop them.
My nephew teaches in China, and he said they are teaching facts. They can reel off the facts, but they are not teaching the students to think. You ask them to think outside the box, and they're lost completely. That was his opinion.
Wow.
Oh, we've been doing
Yeah, they're
that
economy,
for years.
Well, that's because we keep pumping our money into it. We keep pumping our money into it, buying the stuff they make.
Yeah, right.
If the desktop molecular manufacturing takes off here, then we won't need their enormous sufficient factories there. We won't have to pay to have the stuff shipped over, and we won't have to have them build it.
But we have one major problem in this country. We may come up with ideas and technology, but we've been backwards as far as developing and using and applying it. Because that's why all these products are coming in from overseas that we're consuming.
Well, many of those products that are coming in have been copied. The Chinese are very good at copying our technology.
All right,
So also technology is coming out of
producing more engineers than we are.
Yeah, but the new ideas are still flowing out of the West.
Where's the R&D?
But the intelligence is on that side.
Yes,
I didn't
sir.
understand one of your answers. You said that something about people are going to stop here, and then we won't have any fencing if people continue on. Does that mean that developers are always hostile?
Does that mean what?
Does that mean that future development is always hostile?
Oh, no, it doesn't. It just means that if we were to draw an arbitrary line and say, we're not going to manufacture any devices smaller than 100 nanometers, and somebody else says, well, why not? The technology to work at under the 100 nanometer scale exists, and but then if the research from the defenses guys are not able to advance because they can't look at that lower level, and the people who either aren't controlled or have malicious intents does proceed, then we have no defense against it. It's kind of an arms race, if you want to think of it in those terms.
Well, why do you use that? Why do you use that kind of symbolism or that kind of?
It's accessible. People understand it. And most of us, I'm sure, lived through the Cold War and the missile gap and stuff like that.
But does that make it hostile? I mean,
Oh no, it doesn't. But it's the only way you can protect yourself against it is to already understand it. If you try to hide from it and deny that it exists, then well, that's no better an answer than a theist saying.
well, all you have to do is survey the public, and you know the public denies lots of things.
Yeah.
Well, it's like the gene therapy, using using stem cells.
Stem cells.
Stem cells.
Research where they say, moral issues make them stop, on that. I mean, well, it's still go, why? I mean, if it's there.
Yeah, we could have cured diabetes by now if there hadn't been so much infighting.
Or a lot of, serious illnesses. I mean, did they recently with stem cell? Oh, I'm sorry. Go ahead. I mean, I was.
Aren't you afraid of HAL, 2001 Space Odyssey?
Not if we can unplug it.
Where the
No, why do you never unplug it?
Billigan.
Back in the late 1960s, Buckminster Fuller wrote a book, Operating Manual for Spaceship Earth. And the book was about the same concept of exponentiality, but he wasn't looking just at technical growth. He was also looking at our ability from a social standpoint to interact with each other. And he was pointing out that our problems are growing exponentially. It's not as if you can say, well, every generation has its problems, which you hear sometimes just people will just dismiss talking about what they have today. But his point is that it's really not the case. We have more problems each generation. It's the same growth that you've got here. And he was optimistic that we were going to be able to resolve our problems largely because of the technical growth.
Yeah,
and if you go back and read his predictions, he missed he was way too optimistic. It's not encouraging.
Well, then
So the science is still, it's a problem that's been recognized for a long time, but the science way outstrips our ability as human beings to deal with each other.
Well, it sounds like we better push the science faster to solve more problems.
The science is causing more problems, like you said, so we have to keep up with that too.
You got to do more science to solve more problems, which causes more problems. You have to do more science to solve more problems.
People cause more problems. I'm not saying per se
Oh,
science
no.
causes the problem. It's a sociological.
Yeah, there's that.
Well, you're talking about with religion, families and so forth, not family too, is where it seems like to me though that they stop to where they are. And this is my belief, and that's it. But they're basically in a different culture or something because they don't want to even think about believing anything else.
Regarding it is true. I've tried to stop using my belief as I
The
can.
joke when they said, what was the joke that she had mentioned? She said, you can't tell somebody, that is fixed in their ideas.
Oh, yeah. It's like trying to bring the Amish into the 21st century. It's like trying to bring the Amish into the 21st century. They're still happy in the 18th.
Yeah, right.
Fine, and they're not hurting anybody.
Yeah.
Heck, maybe they're the backup.
Yeah.
Why would you want to disturb those? They're happy.
I wouldn't. That's what I mean. I'd rather put them in a little petri dish or something and keep them safe.
I've read a lot about the Amish, how they abuse the girls, the young girls. The brothers had sex with their daughters, and the fathers had sex with the brothers had sex with their sisters. They force them to have sex with them. They keep it within the family. They say don't tell the authorities outside.
Wow.
Where'd you get that?
It's been documented. One girl went to the authorities on the outside and told all about it.
Steve, one of the things I'd like to point out is that we've already got a sort of singularity type of phenomenon going on, and that is in the internet. Where the amount of information that you can access from your desktop computer has grown fantastically in a very short time.
Yeah.
And that's an illustration of sort of phenomenon that we're going to encounter. And then, if I may, I have an answer to of a sort to Bill Frick's problem of the growth of the problems. But Mr. Fuller,
It's not Bill Frick.
Whoever the problem is, but it seems to me that what we have to do is to move our science of morality and ethics much faster along than we have done up to now. I mean, that's the answer to this thing. How should we behave? Are we studying the consequences of all the different things that we're getting into?
Well, in defense of Buckminster, he's basically saying what you're saying, Bob, that we need to have that dialogue and we need to get it underway right away. In other words, same thing, but he was saying this in the late 60s, and my point is that dialogue is largely still missing.
Well, it has to be started by groups like this who are studying ethics and morality.